So to start, I'm going to open GIS, and I'm going to add all the files that I have in the Riverfront folder in the Week 9 folder. So I'll just quickly drop that stuff in to my data frame. So I have that right over here, Week 9. What we're going to do is we're going to I'm going to show you guys a few examples of the kind of work that I do at my office. So some of the files that I'm going to share with you are actual project files from my work. So just FYI, you can't like take any of the work and then present it as your own work in studio or anything like that. That would be some sort of violation of academic integrity, which is important, I guess. So in here, in this folder, I have a DEM, and this is going to be of the North Riverfront master plan that we developed last year. So I have a DEM of the coastline right adjacent to the Mississippi, just north of downtown St. Louis. We have a bounding box. We have some building footprints. The building footprints has, in the attribute table, building height information. So this is something that I already set up using LiDAR data to get the building heights, parcel information, and then also a water boundary for the river. So quickly using this data here, we're going to set up a base Infraworks model. So just like we did last time in class, yesterday, you can go into Infraworks. You can go into the new button in the upper left corner. Give it a name. We'll call this one North Riverfront Model. I'm going to save this on my computer, which is the second drop-down menu there. And then in Model Extents, you check the box to find Model Extent. So then I'll click on Load Extent from File, and then I'll navigate to the bounding box, B-Box Riverfront. And then Use Data Extents, the second option of these two buttons here. Then click OK. Okay, so that's it. Again, this box here that you see is the same exact box, or the same exact bounding box as this shapefile here, and it's already geolocated correctly. So if you zoom out, like I showed in last class, you'll see that it is in the St. Louis region, which is great. And now I gotta find it again. My tutorial is already going bad. Here it is. This is a little dot. Okay, found it. I'll never lose you again. Never, never. Okay. Okay. So what we're gonna do now is we're gonna add the terrain data. So click on in the data sources option here. If you forgot how to get there, you click on the red button in the upper left corner, and you click on this thing that looks kind of like a series of cubes, and then click on data sources, and it brings up the data sources window. And then you want to click the drop-down arrow in the upper left corner here, and then click on raster. Raster is the data set that you use to bring in topographic information. So we're going to go back to the box folder, and then we're going to add the DEM0 file. So do that. Then double-click on that. And then it already automatically filled in the correct coordinate system, so this is all good. You don't have to do anything except click on Close and Refresh. And let us do this thing. This data set was something that I downloaded off of the Missouri GIS database. It is based off LiDAR data, so it's very high resolution topographic information. And just in case you're curious on where it actually is, I'll just open Google Maps just to give you a sense of where it is. This is the riverfront site right over here. This is the arch grounds right here. Our site's right here. So you can kind of see this is the old casino docking area. That little thing there is this little thing right here. So now that we have terrain information, let's bring in aerial photographs. So I didn't have any aerial photographs in the GIS file, but there is actually a trick in Infraworks. You can bring in Bing aerial imagery. I mentioned this last class, but I didn't show you guys. If you click on the button right to the right of the regular Add Data Sources tab, you can actually add data sources from the web. So at the very bottom of this connection type dropdown, there's a Bing Maps option here. If you click on that, you can bring in imagery from Bing Maps, basically just downloading it straight from the web. And the smaller the number, like the smaller the number per pixel, the higher the resolution. So for this class, I'm going to go for this 18 at ground resolution, this guy right here. Click OK. Then click OK in the next window that comes up. And then you're going to have to right click on this guy and then click refresh. Then give it a second to download the information from the web. And you see it automatically brings in aerial photography.
So it just automatically puts it on your terrain and nothing more?
Correct. That's it. This is the easiest way to get aerial photography for your site if you don't want to find ortho imagery from, say, USGS or whatever. Now, this is not the best quality imagery. So as you can see, if you zoom in, it gets all blurry and pixelated. That's not the point of today's class. You can always find higher resolution imagery anywhere on the web, but this just gives us a quick base to work off of right now. Okay, and then the second thing we're going to bring in is the building footprints. So go to the shapefile data source option here, and then go to buildings. So click on the buildings shapefile, and click open. Then double click on buildings. And then in the data source configuration, you want to make sure the type is set to buildings. You're going to want to make sure the geolocation is set to the coordinate system of your GIS file. Again, to double check that, you just go in here, you double click here and make sure it's, right now it's Missouri East feet. So that in Infraworks is MO83EF. It's this one right here. And then we're going to set the building heights. So real quickly in GIS, if you open the attribute table for the building footprint layer, you see I have building height right here, ground elevation, Z, and then elevation. These are actually these two things are the same thing. Ground elevation, this is the actual elevation of the building on the ground in meters. The units here are confusing, and that's my bad. These are here in feet, these are in meters, and these are in feet. And the only reason it is that way is because I'm a bad person. So I'm sorry. Maybe one day someone will forgive me for my mistakes. But for now, I am cursed.
You added that data?
So with that set up, let's go back into Infraworks just so you know what the situation is. So in roof height, we're going to set that to be, if you click on this, we're going to set that to be the Z right here, Z. Actually, no, we're going to set it to elevation. Z and elevation are actually the same exact number. There's really no difference. I'm just choosing elevation here. And this number here is the roof height above sea level. So you want to check this box here, because if you go back in here and look at these numbers, the elevations are like 500, 400, 600. Obviously, these are not real building heights, but they are the building heights above sea level. And that's what you get when you cross-reference that information with LiDAR, is you get the elevation above sea level. So that with that box checked, you should be good to go. But I'm going to set some styles first. So in this next window right next to that thing, I'm going to click on the little pencil next to real style. And you can pick any one of these building facades if you want, but I recommend choosing just a simple white color, because otherwise it'll look weird. And then on I'm just going to copy this line here using Control-C and just paste that into the next two lines like so. That way everything is just a nice clean white box. If you click on close and refresh, you'll see that you got building footprints at the correct elevation on your site. And sometimes you get stuff like this where the building is at the edge of the actual model. When stuff like that happens, I just delete that because it looks weird. So that happens in 2 occasions in this model, there and there. Okay, so we have an Infraworks base basically set up. This is all ready to go. We don't have to do anything else to this. But what I want to show you now, because now is how I integrate my design work into this thing here. So I'm just going to set this aside. Whenever you're not using Infraworks, I recommend just zooming in to some corner of the model and then zooming in real close. This makes it so that it's not rendering the entire model in the background, and then turn off high visual quality as well, So now this does not take up any CPU resources. So in GIS, I'm just going to export these shape files here. So I'm just going to zoom into the bounding box area, like so. That's this little box right here. I'm going to right click on B-box, data, export to AutoCAD. And this is, again, stuff you've done already a million times. By now, this should be second nature. So drag in the layers that you want to export. Pick the location. I'll save this on my desktop. I'll call this one North, or just NR for North Riverfront. Go to the Environments tab. Click on Output Coordinates, same as Display. Processing Extent, same as Display. Cartography, same as Display. OK, OK. And now you're exporting it all OK. So the reason we do this is because when you are doing your design work, actual designing your park or designing your building, you always want to make sure that your building is geolocated so it knows where it is in reference to a coordinate system and to this GIS base. This makes it so that when you integrate it with Infraworks later, it's much easier. In the box folder that I set up for you guys, if you go back to the week 9 layer, there's already a Rhino file called NR model. So just open that if you want to follow along. So I'm going to go here. NR model. Open that up. And this is the this is actually my work. So don't steal my work, otherwise I'll be sad. I won't be angry, I'll just be sad. You know, I can't do anything about it. I'm a weakling. I'm just gonna cry and be sad. And you stole my project and. Okay, anyway. So this model here has already been georeferenced. This already is located correctly. And the way you know that is just by typing in import and then importing that NR DWG base that you just exported. And as you can see, it comes in at the same location as the model set up. Everything was already located correctly. So I just set this up for you guys now, but this just proves that this model, this 3D model, is already geolocated correctly. So I'm going to turn off the GIS layers for now, and we're going to focus on this thing here. So because everything is geolocated correctly, you could, in theory, just export this building straight out, or this park straight out and into Infraworks. But what I recommend doing, actually, and it's a little hard to see here, basically, whenever you georeference your models in 3D, sometimes you will notice that the model has a flickering quality to it. It looks like things are just kind of like jittery and shattery. For some reason, today this doesn't look bad. It's probably because the resolution is low. But sometimes there has a jittery quality to it, and it's not very nice. And the reason it has that jittery quality is because since the model is georeferenced, that means it's like a million units away from the origin. And what's happening is that the units, the numbers that are generating the coordinates of these shapes are way too big, and it's losing its decimal points, basically, due to the large coordinates there. So because it's losing its decimal points, it's losing its precision. So you always want to work as close as possible to the origin of the Rhino file as possible, but you don't want to ever lose the geolocation of it. So what I recommend doing is creating a translation vector. What does this mean? Basically, all this means is you create a point, right? Just create a point anywhere in your model, and ideally the point would be close to the model. So I'm just going to move this model up, say 420, because I know this area is about 400 something feet above sea level, and make it close to the actual model itself. And then you want to get the coordinates of that point. One way to do that is just to open Grasshopper. I think there's a way also just to look it up in the Rhino file, but I like doing this method because I always use Grasshopper.
Is this also a reason why?
So in Grasshopper, really simple, I'll just set a point, set that point here, and then just deconstruct it to get the X, Y, and Z values of that. So I'm going to copy and paste 3 panels like so. And now you know the X, Y, and Z values of that point. this point cannot move. So I'm actually going to create a new layer in Rhino, call this one origin, then move that point onto that layer, change object layer, then lock it so it never moves. And then I'm going to open a, actually I'll save it into the box folder just so if anyone wants to follow along, they can. And just call this, and then just what you do is in here, just copy, right click on the thing, copy data only, which is right here. And then I'm just going to Control V to paste it. Do the second thing for the next, or do the same thing for the next item. Then do the same thing for the next item as well. Then save that file, minimize it, and then you're done. Now all you do is you take all your entire model, basically you take every single layer on your model, except for the origin point. This must stay in that location because if you want to move back, you got to have that as its point. Hit M, use that point that you made as your starting point. Now everything moves with it, and hit 0, 0, 0. Now the entire model has now moved close to the origin, and you just zoom to that, and now you can see it's close to that Rhino origin grid. And now any flickering or any model problems you might have had in the past will not occur anymore. But you now know the coordinates to move it back, which are right here. So if you ever want to go back to your georeferenced location, just use these numbers. So with that being said, I'll show you how this works. I'm going to turn off the park first, and we're only going to focus on the context. So for instance, this is a Martin Luther King bridge, this little bridge thing here. I'm going to turn off all the other layers. And I'm just going to right click on the bridge group here, select objects, then go to export selected in Rhino. Then I'm just going to create a new folder on my desktop. I'll call this one Infraworks. And then I'll save that as in FBX, which is my recommended format for bringing Rhino data into Infraworks. And we'll call this one MLK Bridge, because that's what the bridge's name is. And then always want to make sure that you save the FBX as meshes. So I want to mesh it right here, click OK. And as I mentioned in last class, I generally recommend keeping that slider around that 75% mark. So click OK. And then go back into Infraworks, you're ready to go. So then go into the data sources option, click on 3D model, go to the folder where you saved your stuff. Here's MLK Bridge. Double click on that. We're going to save it as a road. In 3D model, you want to flip the Y and Z guy here. So now the bridge is in here, as you can see. Right now it looks kind of dark, so actually what you can do is you can override the material to make it like a nice clean white material. So if you check this box, override all materials, you can give it a color. Right now it automatically defaulted to the pure white, which is what I want, but if you want to be groovy, you can give it a green color, which makes no sense, so just give it a white color. But that being said, why not? This is just a tutorial, so green it is. And then in geolocation, you want to set the coordinate system to be Missouri 83 east feet, which is the coordinate system of our GIS file. And then in these offset numbers here, this guy right here, this is where you bring in these numbers. So this is why you save these numbers. So just Control C, paste that X, Y, Z, close and refresh, and you see it works flawlessly. It works flawlessly. The model is now in the exact location that it should be. And it won't have any of the artifacting effects that would have happened if you just brought this in at its geolocation, which is the flickering. Nice. We got a nice green bridge. It looks good. Looks great. Let's bring in the other elements of the park as well. So let's bring in the rail line, which is the terminal railroad here, and let's also bring in the flood wall. So I would just bring this in as one group just to save time. I would usually bring these in as separate elements, but just to save time, I'll bring them as one. So export selected, call this one rail and wall.
Why do you have to do them separately?
In case you want to turn things on and off, or you want to change objects.
So when you bring it in, that just makes everything one group?
Correct. It just makes it as one solid element. For instance, yeah, I mean, this is pretty much up to you how you want to do it. We can totally bring this in as like 5 different elements if you wanted to. But just for this tutorial, I'm going to do this all at once, just to save time. So I'm going to do the exact same process here. So bring in the 3D model, rail and wall, double click there, do a road, go to 3D model, flip that Y and Z. You can override the materials, and this time we'll make it white. Then geolocation, MO83EF, and then again, copy and paste these numbers into the X, Y, and Z lines here. That was 420, I'll just type it in. And there you go. As you can see, the wall comes in an exact location. Perfect. And because I don't like that green bridge anymore, it's bothering me, I'm just going to make it white. There we go. Also, I forgot to bring in the water, so I'll bring in the water. SHP, it's in the box folder, the water area. Double click on that. We're going to set that as a water area. Geolocation, make sure it's set to the MO83EF. This is just a shapefile. It was never moved, so we don't have to offset anything here. And then just click on close and refresh. Now, you're going to notice something about this water when it refreshes. I think you're going to notice, yes. You're going to notice that this water, see what it's doing here? It's like draping onto the topography, which is weird. Water doesn't do that unless, I don't know, you're on some different planet where water does this. But unfortunately, we live on Earth. And unfortunately, we live in America, you know, where things are going horribly. So we have to make sure this water looks real. Not that the country or the planet we live on has anything to do with what we're teaching in this class. But I digress. So one thing you can do is you can set the water level to be some specific elevation. So if you move my mouse around here and hover, say near the water edge here, you can kind of see that at the Z value near the bottom left corner, it says like 406 feet. We're going to just set this water level to be that elevation. So just set the water level to be 406. Close and refresh. And now the entire water level will be at one elevation. This is not the same thing as doing flood events. That's different. This is just visualizing water at one specific level. And this only works at that level. And now if you turn on high visual quality, whoa, look at that. Everything's like reflecting and And so, yeah, the water is not blue, unfortunately, here, so I might use that trick I showed in the last class where you go in here, go to water areas, turn on a highlighting color, and set the highlighting color to be a nice brownish yellow. Okay, whatever. So, great, everything was good. So now, I've been digressing a little bit. We have a park, we have a bridge. Okay, but now you want to worry about your actual design project. So that's where we get into this layer here, LSP. And this is a little park project that, that I worked on at Farm Studio. So GRG, Great Rivers Greenway, they own this little parcel right here. That green's really bothering me, so I'll just turn it off. They own this little parcel right here, and their plan is to do a little riverfront park right in front of their greenway. So they have currently a bike trail on this part of the river right here. It's a really nice bike trail. I encourage you guys to use it if you ever have free time, which you don't, but that's okay. But in any case, that's supposed to be a joke. This is in the future is going to be a little park. You're supposed to laugh at my jokes. So what we could do is we could just take this whole thing, right? And we could just export it straight out of here into Infraworks, right? You could add some textures in here and you can do a lot of fun stuff. My preference, and this is how I do this at my office, is I like to bring my model into 3ds Max first and add my textures in 3ds Max and then bring it from 3ds Max into Infraworks. And the reason I'd like to do this is because I think 3ds Max is has much more robust texture editing platform than Rhino. So at this point, this is pretty much just me telling you how I do things. This doesn't mean you have to do things this way. So with everything set up in here, the way you want to set up your model before you bring anything into 3ds Max is you want to always organize your design by material. So in the LSP folder, which stands for site plan, landscape site plan, I have every single element of this design already organized by its material. So I have curb, which is concrete, wall, which is also concrete, but I just separate them to give them maybe different colors of concrete. Stairs, concrete pavers, sand, rubber surfaces, the ramps, green areas, which is, vegetation, paving, and obviously wood decks. So everything is already organized by its material. And this makes it, when you bring it into 3ds Max, much easier. So the way you do it is you select your site. Everything in Rhino is a NURBS modeling usually. And 3ds Max is a mesh modeling tool. So you always want to mesh the design first before you bring it into 3ds Max. So I just type in mesh. And this is the same exact meshing tool that you saw when you exported to FBX. Again, that 75% mark is a nice sweet spot for me. Good level of detail, but not too high in mesh cells. So it's going to mesh it right now. And now what happened is that it basically meshed the whole thing, and so there's a mesh and a surface kind of overlapping each other right now, as you can see. I only want to export the meshes, so you type in SCL mesh. The only thing that's a mesh is the design right now, so I can use this tool freely, and so only the meshes have been selected in the Rhino file. And you go to File, Export Selected. I'm going to save it, and I'll save it in here, it's fine, in the Infraworks folder. To the best format to bring Rhino files into 3ds Max is actually DWGs. AutoCAD DWGs. I have experimented with every single one here, and this is me teaching you now, after all my trial and error, that DWG is the best format. I'll call this one North Riverfront. God, I can't spell today. Riverfront. Now this is important. You want to always make sure that your export scheme is set to solids, 2004 solids. Otherwise the meshes won't convert over. Then click OK. And then what I do is I just undo, right? Undo the mesh. So now there's no more mesh. So whenever I want to change anything, I just change it in here, and then I mesh it again, and then I export it. So that whole meshing process has been undone, but the export still exists. So I have 3ds Max open now. What I'm going to do is I'm going to go to the upper left button here, and we're going to import. Click on import, and the little arrow next to import, and you can link AutoCAD into 3ds Max. Also, you can link Revit as well, and this is how I bring in, like, if our architects have a building, I bring in the Revit models using this link Revit button here. We're going to start with the link AutoCAD button, so click on link AutoCAD. Actually, I'm going to cancel real quick. So go to import, link AutoCAD, and we're going to go to the AutoCAD file, which is the North Riverfront DWG right here. Click open, and they're going to bring this in this manage links dialog. So I have a Rhino presets already made for this. I recommend creating one, so the easiest way to do that is just go to presets on this little right-hand thing here, and then click on new. And call this one Rhino 2. I already have a Rhino 1, but that's okay, Rhino 2. And then you want to click on that Rhino 2 preset here, and then click modify. And the important thing here is you want to go to advanced, and it says derive AutoCAD primitives by, you want to click on layer. All this means is that when it brings the model into 3ds Max, it's going to like group everything that's on one layer in Rhino as one object. And that just makes texturing the whole thing like way, way easier. That's all you really need to do. So click on save. Then in the attach tab here, you want to set the preset to your Rhino preset. And then you always want to make sure you check the rescale button and make sure that the units of this thing is the same units as your Rhino file. So in here, if I type in units, it should be feet, which it is. So it's everything's to feet, so click on attach this file, and you're done. So look at that. You have a Rhino base built into 3ds Max, and it looks great, right? So, and as you can see, if I go into the this little sidebar here, you see that each layer is wall, sand, stair, orbit surface. It all comes in as its own object. So, like the sidewalk, the curb, the decking, it's all one object. I just click any part of that object and it all selects at one time. So this just makes the texturing process way, way easier. I like to use the layer explorer. So in the bottom right or bottom left corner, this little yellow thing here, if you click on layer explorer, this is basically the same organization that you would see in Rhino. Okay, so almost there. We want to add textures to this now. So the way to add textures, you hit the M key on your keyboard. Hit M. M for manager, or M for monkeys, or M for meanie, you know. Or I could just said M for material, but that would have been too obvious. So this is the material editor, and this is one of the reasons why 3ds Max is powerful, is because it has a very robust material editor here. The way you actually bring in materials, it's going to look like Grasshopper. I'm going to go in hopefully you guys will have the same, sometimes the material browser it looks a little different for different machines, but in the side of the materials here, there's a scan line material option here. I'm just going to bring in a standard material. Just drag it in, and look, it's like this little Grasshopper kind of like wire interface. You know, you can drag wires up. So this is how I add materials into 3ds Max. So I'm just gonna, my screen is a little cramped here. So what you do is, and this is something I actually didn't help you guys. You actually need materials to set. So I have on my computer a texture folder here, and this is all the textures that I've saved, you know, that I find very useful. So I'm sure you guys have your own texture folder as well. So what you do is in the diffuse color line, which is the second line down from this thing here, you drag out, and it allows you to pick a kind of input for that. So in the general line here, there's a bitmap option at the top, which basically means a picture. So you click on bitmap, and now you can navigate to any texture you want. So I'm going to go to my texture folder, and I'm going to go to a grass texture, say this nice neon green grass. So click open, and now you've created a grass texture. Very simple, and you can do a lot of other things with this. You can change the glossiness of this. You can add a bump map if you want. A lot of different things you can do to this. For now, we're just going to add a simple image onto it. But you can see there's a lot of options that you can use to change. You can a lot of options you can do this with. So with this thing here selected, not this thing here. This is just an input. This is the actual texture itself. With this selected, I'm going to go into the 3ds Max interface. I'm going to select the object I want to apply this texture to. So in this case, it's going to be the green space. So I'm going to click on the planting object here. You can just click on it in the layer here. See, if you click on the object, the line and layer, it automatically selects the object. Another trick in 3ds Max that, you know, a few commands you should know. If you hit on Z, just hit Z in 3ds Max, it automatically zooms to the object that you want to look at. If you select an object and hit the space bar, that locks that selection. So you can click all you want and it won't lose that selection. If you hit space again, it unlocks that. So those are a few good shortcuts to know. I'm going to click on the grass or this planting area. I'm going to click on this texture right here. So both are selected. I'm going to hit this little button. It's very small in the upper left of the material editor. It's assign material to selection. Click on that, and now the material has been dropped onto the model. And then you want to click on this button here, which is show shaded material in viewport, so you can look at it. So now you can look at it. So I'm going to minimize this for now. We're not done yet. As you can see, the texture has applied, but it looks a little weird. So the last step to finishing your texturing in 3ds Max is to select the object, go to the modifier button, which is on this right-hand side here, the modifier. And this is why people hate 3ds Max, because none of this makes any sense. It's so unintuitive. It's nuts. So on the right-hand side here, there's all these tabs here. And then the second tab is the modifier tab, right? And so you go to the modifier tab, there's all these modifiers that you can apply to this element. And there's so many modifiers. I don't even know like half of these. At the very bottom, there's this thing called UVW map right here. If you click on that, it's going to add a UVW mapping system to this texture. As you can see, what happens is it's created this plane and it's projecting that texture straight down onto it. See, now the grass looks all stretched out. So, and there's different mapping algorithms. There's planar, cylindrical, spherical, shrink wrap, box. Planar just means it's going to create a plane and just going to project straight down onto the object, which is perfectly fine for grass texture. And then what you can do is you can adjust the length and width and then the tiling of that texture. So in the length line here, I'll type in like 10. As you can see, that's now shrunk that texture map to something at 10 feet. Make the next one 10. And as you can see, now it's tiling this small little square here all across this object. And it's nice and clean, nice and simple. If you click on the gizmo below the UVW map modifier, and again, I apologize, let me pause the video first. Okay. And you can adjust the tiling by going to UV. You can even just like click the arrow here, you can just like move it up and down, you can slide it around. So you can adjust the look and feel of that texture, right? If you click on the gizmo button here, you can click on any of these moving transformation options, such as move or rotate. So if I click on move, for instance, you can see what it does is just basically slides the texture around. You know, it just slides it around. Not that that's useful, but in case, you know, you want to, like, this is good for paving patterns. You want to align that paving pattern with the site, for instance. You can also rotate it using the rotation tool as well. So you can see I like this because of these reasons, because it just makes texturing just a lot more, you know, better than the other methods. I don't know if it's better, if it's as easy or hard in other programs. So I'm going to pause the video. All right, so I have already, it took me about 10 minutes to do it, but I did the same process that I showed you with that one piece here, and I put textures on every part of this model here, right? So it's all been textured. And as you can see in here, I've created a bunch of textures. It's really simple. So with all that set up, we're ready to go. So we just select the entire model, drag and select, and then go to the side here, go to export, then export selected. I'm gonna save it into my Infraworks folder. Call this one, save it as in FBX, so right here. Call this one NR Park, that's the park project. And then in the export settings here, you want to do a few things. You want to make sure that the units, this is the most important part here, is set to feet. The same units as your coordinate system and everything else. With that all set up, click OK. OK. And then in Infraworks, we're going to bring in that model. So go to 3D model. We're going to go to that folder where we saved everything. It's NR Park. Double click on that. And then we're going to set it as a road. And then in 3D model, if you click on the 3D model tab, in a second it should just load up. So you can see that entire model has been loaded up with all the textures and everything looks good. Maybe the paving size is a bit too big, but we can change that later if we wanted to. So this is all good. We don't need to flip Y and Z because this was an export from 3ds Max, and 3ds Max uses the same YZ system as Infraworks. So it's a little different from bringing it into Rhino. And then in geolocation, you want to set it to MO83EF, which is the same units that our GIS file set up. And they want to use the same exact offset numbers here that we saved here. Because again, this export from Rhino was the moved model, the model that was moved closer to the origin. So you gotta move it back. So copy this in X, Y, Z, 420. And then all that set up, click close and refresh. And it will come in correctly. And as you can see, it worked perfectly. Now, it looks weird because the model, the site is in the actual existing terrain. So that's why it's all overlapping on top of each other. So to resolve this issue, what we can do is we can cut a hole like John hole, but like a terrain hole, spelled differently, into the terrain. I hope he doesn't see this video ever. I hope. Oh no. No. Oops. So the way you cut a hole in this model is you go to the coverages. So in this little arrow here, this little pencil here, if you go to land areas, this little button here, you can draw like, you know, colors or things that kind of overlay on top of the, actually not this one, as it's, sorry, I think it's in, yeah, coverages here. There's this thing called terrain hole right here. So you click on that. Basically all that does is it just cuts a hole into the model. So we're just gonna draw an outline kind of around the site that we're working on. And if you want to be more precise, you can create a shapefile that had this exact boundary, but we're just doing this for a demo, so this is okay. So just kind of, so then double click to close. Let it do its thing. And let me move this and close this for now. Then as you can see now, it's now nicely set into the landscape. This whole model has already been set at the correct elevation, so I don't have to do anything. I just need to turn on the shadows and make it look good. So all looks good now. All right. And then what I did in the final design of this is we added some furniture. Some furniture you can download from SketchUp, and we also had some trees and some people. I'll show you, know. So the next thing I'm going to do is we're going to add some road features to this site. Right now it's using the aerial photography as the base here, but in this particular instance, I do want to add a road just to make like this upper portion here, which is a road, nicer, and also maybe this bottom portion here. So as showed in the previous video, you go into the roads button in this little pencil tool here, and you can pick any one of these road styles from the drop-down list here. So for now, we'll click on, if you're following along, click on the sidewalk and green space option, and then just literally just draw, you know, a road across the site. And double click to close it. Just give it a second. Do its thing. So I might not have drawn this correctly. It's kind of overlapping that piece there. Let me see if I can edit this. I guess I can't. Okay, whatever. This little arrow here, error here is not a big deal. I'm also going to draw a road on the bottom here. So I'll just go to road, and with the same style selected, I would simply just draw a line to represent that road. What I'm going to show you now is how do you actually you can adjust the actual road profile itself. And this is useful, say you want to add a bike lane or you want to add trees to your road. You can do that in Infraworks. So in the style palette, so if you click on the little pencil on this side here, there's a little style palette button right here. If you click on that, this brings up every single element that you can bring in, including the road profile. So the very bottom of this list, actually not kind of near the bottom list, there's all these road profiles that you can use. If you, in this case, we use the sidewalk with green space layer. If you select that object and you click on this duplicate the selected style, it makes a copy of that road here, and we'll just call this one road 2 or something. You can edit that road profile, so you can add street trees, you can add bike lanes, whatever you want. So I'm going to click on road 2, and you click on the little pencil right next to that. And this gives you all the road profile options that you can adjust for this thing. So down at the very bottom, there is a preview of what you got here, and as you can see, you can adjust the road width. So right now the road width is 9.8 feet, which is actually too narrow. Generally you want to go for like something like 11 or 11.5 or 12. 11 to 12. So let's split the difference and do 11.5. So we see if you do that, it should have automatically updated. You can adjust the green space as well. So right now it's a 2-foot green space. Generally, actually, it's nice to have something like at least 5 feet. Otherwise, it's too skinny. But actually, right now, nowadays, people don't like these little green islands because they're actually kind of pointless. It's actually better to put the sidewalk closer to the street. So maybe you just get rid of that. So if you click on this green space layer here, and just click on the X, that gets rid of that. And so now you just have a sidewalk. And then the sidewalk, let's make that 6 feet. 6 feet is a nice, 6 feet is probably the minimum I would go for a sidewalk. 10 feet is ideal because you can add some benches and street trees and everything. And then what you can do is you can add furniture. So if you go to this decorations button right here at the very top, you can add a decoration onto any feature you want. So let's say you want to add a street tree onto this sidewalk here. If you click on the sidewalk option on the decoration target, then click on this plus icon, you can pick any of these objects from the list here. So let's go to the vegetation. Let's go to pick one of the trees. Let's pick this tree right here, which is a pretty good one. And as you can see, it adds the trees at various intervals. And you can adjust the spacing here. Right now it's set to something like 30. Maybe set to something like 20 feet and see how that looks. Yeah, more trees, which is better. You can set some offsets as well. So maybe a spacing offset, maybe do 2 feet. Or in maybe track offset 2 feet. That moves it in a little bit more, maybe 3 feet. You can add multiple decorations as well. So if you click on the plus icon again, you can add, say, an oleander. You can add a potted plant if you want to do that. Why not? Doesn't look that great, but whatever. Let me make the spacing here like 50. So you can just play with these numbers and just make it look right. You know, that looks okay. So that's how you kind of adjust the road profile. And then when that's all good, you just click on OK. You have a new road profile here. And all you do is you just drag that road profile onto the element in the model, and it should update accordingly. Okay. So that's all set up. We're gonna do a few more things, and then we're gonna call it quits. One of the ideas that we had for this park is to create a connection up to the casino right here. So we would cut a road through this parking lot here, and it will lead you straight to the casino. So I'm going to draw another road. I'm going to use that new style that we created. So I'll go to road. I'll find and it should also just populate in here as well. So yeah, the road 2. I'm going to draw a road from here down, and again, Infraworks resolves intersections, so it automatically draws the intersection. I'm also going to draw one this way as well, so we'll do that. So what I'm going to do last to wrap up this class is add a building to this. So we had this idea of adding some residential apartments along this area right here. So for this class tutorial, I have in the box folder there's a Revit building 3ds Max file, which is basically a Revit model that I got from one of our old projects and imported that using the link Revit button in 3ds Max. So I'm gonna just open that. This has already been saved, so I'll just open up that guy. Oops, it's right over here. And because it's a model that was imported straight from Revit, this is not geolocated. So we're going to bring this in using the traditional drag in XY, and we're going to rotate it and whatever. So I had already thrown on some textures. You probably don't have the links to these textures yet, but if I hit M, it's just simply a brick material, a white material for the building floor plates, and then also a glass material as well. So everything's set up in here already. This is the exact same method that I used in the previous park model, using the material editor and then dragging it onto the elements of the building. Bringing in Revit models does the same exact thing, where it isolates the different families into single objects. So everything, for instance here, all the glazing is on one object, so you can add materials all at once, and it's very, very convenient to do that. So again, select the whole thing, go to export, export selected, call this one building, and make sure all the units are set to the units of your model, so in this case feet. So click OK. And then that should have been exported. And then let's go back to Infraworks, and then let's go to the data sources button thing here and go to 3D model, add that building. So here's building, add that. Again, it makes no sense, but we're going to set it as a road just so we can turn it on and off. You can double check the model that it came in correctly. So here it is, it looks good, came in correctly. And then I'm going to use this time I'm going to use interactive placing. So click on that. And now we're just going to drag and drop it into the model here. So just double click to drop it, and close and refresh. So now our model has been dropped in, and because we're just manually dropping this in, I'm going to move it and rotate it to kind of align with the roads on the site. Like so. So again, if you were building your model or in Revit, this would be my recommended method of doing so. Again, it's just importing the Revit file into 3ds Max using the import Revit button. I just clicked on this button, the link Revit button. It's very similar to the link AutoCAD button as well. I think you guys can figure that out. But now what I'm going to show you guys is, say for instance you have this brick texture, on the facade right now. You don't like that brick texture. Let's say you want to change it to, say, I'm going to double click on this and change it to like a, I don't know, maybe something that looks more like a travertine style. This is Portland stone, but it looks kind of like travertine. Kind of more of a pale look to it. The texture has changed. So you select this whole thing, export, select it, and save over that same FBX. Save. Yes. Okay. All the settings have been remembered. You can just simply refresh this link here, and it will just update that model with the new texture changes you applied to it, and should be in the same location and everything. So it's all good. So this is a very nice, convenient way to work on design and also work on your final like site visualizations simultaneously with the whole project.
How do you export out a final image? Just file export, or do you have to like render?
I showed this in the previous class, but to say I do render, you just do the create snapshot.
Oh, that's right. Okay.
Yep. So the final thing I'm going to show you guys is how you can integrate one last piece of data into this Infraworks model, and that is a site plan. So in the tutorial folder, I have this site plan here. This is the actual site plan that we developed for that one building. It's not in St. Louis, but it was the site plan. So we had this little plaza design and we had this green space and everything here. This was just a Photoshop file that I exported as a PNG because PNGs preserve transparency, which is good. You can bring this site plan straight in as a texture into Infraworks really easily. So in Infraworks, we're going to go to the import raster option. I'm just going to turn off, import raster. I'm going to navigate to this guy, LSP2. As you can see, it has a transparent background. This comes in as a terrain overlay. Any JPEG or PNG that you bring into Infraworks that does not have any georeferencing to it, it doesn't have anything to do with GIS, it just comes in as a terrain overlay. And the only way to bring that in is to use the XY drag in and drag out kind of thing. In this case, I'll use XY feet. I believe that worked the best when I was testing this. You click on interactive placing and you see it just brings in, it's a really kind of a big thing, but I'll show you why this works. You can kind of see part of it here. I'm going to double click, close and refresh. And then that element, it's that big, so we're just going to scale it. I'm going to move it so that I can grab a corner. I'm going to scale it down using the little purple handles. Scale it down. I'm going to scale it down so it just mostly fits within the frame here. So now you have your site plan here. You see it automatically drapes over the terrain very nicely. And then what you do is with this selected, you right click on it and you use this place by reference points option here. And now you can just use it's very similar to georeferencing in GIS, but you can click a reference point, say this corner of the image, and you can reference it to wherever it should be in the model. So I think it's right over here. You can pick a second point as well. Let's do let's just do that one and just kind of get it to fit. You can always adjust it later. So I'll do that for now. And hit enter and it automatically drapes it. What I always do is I do it once and then I do it again to refine it. So I did that once. It was not perfect. Actually, what I'm going to do is I'm going to take this building mass here. I'm going to move it down slightly so it intersects with the topography. That way I can get a better registration. Click on that, place by reference points, and then we're going to grab a corner, align that. And then we're going to align, find another area. Maybe let's line this corner here. Let's line. Something like that, maybe. Actually, that's not good. This is the method that, again, my colleagues who aren't GIS savvy, they just want to bring in an aerial or a rendered plan. This is how they do it. It's very convenient. So there we go. As you can see, we're getting closer. Now we have our park design, we have our building design. We did not model any of this stuff here. We just had a render site plan, but that's okay. You can throw it in. As you can see, with a little bit of work, you're almost close. This looks a little weird, right? Because of the existing topography. It's doing this terracing effect. So what you can do in Infraworks is you can do some very simple grading procedures. So again, in the little pencil thing here, if you go to this land areas button here, you can add a transparent grading function. So if you click on this color is transparent, let's say we want to flatten out this plaza space right here so that's aligning with the road. So I'm just going to draw kind of a simple boundary around that area there. And obviously you would be more like careful with how you do it. And then just let it do its thinking. It's thinking about it. So what that has done is it should have flattened out that area, and it kind of did. It's kind of, the grading right now is kind of competing with the road grading here. That's okay. What I'm going to do is I'm just going to go to this thing here. I'm going to lock the overlay so that I don't accidentally change it, and just click on that little thing here, and then we're going to adjust the terrain to maybe lower it a bit, and just get it to work a little bit better. But you can see this is how you can adjust the terrain slightly to match the site. I just did this real quickly. It's not very nice right now, but as you can see, it's flat now. And then the grass area kind of resolved itself into the sidewalk. And yeah, that's basically it. So now you can kind of see, very simply, we have our park design, we have our building design, we have our context. Everything is located onto the site. Everything's nice and shiny when we turn on high visual quality. You can use this to visualize the park with the building. I can turn on the sun and sky option here to adjust the sun and sky options here to kind of get a sense of what it feels like at certain points of the day. And then again, everything is linked into the model, so you can always go back into the Rhino file or the 3ds Max file, adjust the design, relink it, and loop it, keep that loop going. And that, in a nutshell, is how I integrate all my work on day-to-day on my projects. So landscape architecture, and GIS. So again, this kind of goes back to what I was saying when I was introducing this platform, is I feel like this program does the best job of integrating all these things together into one platform. I have my georeferenced GIS files that I use to build the topography, use to build the water, use to build some of these context buildings. I have my Rhino design of my park here, and I have a Revit building that my architects gave me. I have a little Photoshop site plan here that I just simply dragged in. I got all these trees here. You can kind of see with just a little bit of effort, you have a very convincing design project that you can present very easily. And then I would just create a snapshot. So you pick a view that you like, say this one right here. Hit Control-Shift-L to create a snapshot. Pick your resolution. Because you can do any resolution you want. We can do something like 6,000 by, I like to do 2:1 ratios, so 6,000 by 3,000. Save it on your desktop. Call it View 1 or whatever. I recommend PNG formats. Click Save. Let it do its thing. And when it's done, it should take only a couple seconds. Turn off everything. You have your view. So you can now take this into Photoshop, drop in some scale figures, maybe make the trees a little bit nicer, maybe make the sky a little bit nicer. But as you can see, this has gotten you maybe 75% of the way. You just gotta take it the next 25% away, but you saved a bunch of time. So this is how it's done. And that is the end.